Installing a clean ground bus bar in a server room is indeed a requirement for several reasons, primarily related to ensuring a low impedance ground path, minimizing electrical noise, and maintaining the safety of equipment and personnel. Firstly, let's define what a clean ground is in the context of a server room. It refers to a dedicated grounding system that is isolated from the building's main electrical ground. This isolation helps to prevent noise and interference from other electrical systems from affecting the sensitive electronic equipment in the server room. The purpose of a clean ground bus bar is threefold. 1. It provides a central point for grounding all equipment within the server room. 2. It minimizes ground loops. 3. It reduces electrical noise. Ground loops occur when there are multiple ground paths between two pieces of equipment, creating a loop through which current can flow. This circulating current can introduce noise and interference into the system. A clean ground bus bar helps to eliminate these loops by providing a single, low-impedance path to ground. Electrical noise, which can come from various sources such as power supplies, motors, and radio frequency interference, can disrupt the operation of sensitive electronic equipment. A well-designed grounding system, including a clean ground bus bar, helps to attenuate this noise, ensuring the reliable operation of servers and other critical equipment. Now let's discuss the specific components that need to be bonded to the clean ground bus bar. Cable trays, racks, and other metallic structures within the server room should be bonded to the clean ground bus bar. This bonding ensures that all metallic parts are at the same potential, minimizing the risk of electrical shock and reducing the potential for ground loops. The National Electrical Code, or NEC, provides guidelines for grounding and bonding electrical systems. While the NEC does not explicitly mandate a separate clean ground for server rooms, it does require that all electrical equipment be properly grounded and bonded to ensure safety. In many jurisdictions, local electrical codes may have specific requirements for grounding in server rooms, often referencing or expanding upon the NEC guidelines. The NEC Section 250 covers grounding and bonding requirements. Specifically, Section 250.96 addresses bonding of metal enclosures and other metal parts. This section requires that all metal enclosures, raceways, and other non-current carrying metal parts be bonded together to form an effective ground fault current path. This path is essential for clearing ground faults and preventing electrical shock hazards. When installing a clean ground bus bar, it's important to follow the NEC guidelines for conductor sizing and installation practices. The size of the grounding conductor should be based on the size of the largest ungrounded conductor feeding the equipment. NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors for various circuit sizes. The installation of the clean ground bus bar itself should be done carefully. The bus bar should be mounted in a location that is readily accessible and free from obstructions. It should be securely fastened to the wall or rack using appropriate hardware. The grounding conductors should be connected to the bus bar using approved connectors. Ensure that all connections are tight and free from corrosion. The grounding conductors should be run in a neat and orderly manner, avoiding sharp bends and kinks. It is also recommended to use green insulated conductors for grounding, as this is the standard color for grounding conductors in North America. The connection between the clean ground bus bar and the building's main grounding electrode system is also crucial. The NEC requires that all grounding systems be interconnected to form a single, integrated grounding system. This interconnection ensures that all parts of the electrical system are at the same potential, minimizing the risk of electrical shock and preventing ground loops. The connection between the clean ground bus bar and the main grounding electrode system should be made using a grounding electrode conductor. The size of the grounding electrode conductor should be based on the size of the service entrance conductors. NEC Table 250.66 provides guidance on the minimum size of grounding electrode conductors for various service sizes. In addition to the NEC requirements, there are also industry best practices for grounding and bonding in server rooms. These best practices often go above and beyond the minimum requirements of the NEC. For example, it is common practice to use isolated ground receptacles in server rooms. Isolated ground receptacles have a separate grounding conductor that is isolated from the receptacle's metal mounting strap. This isolation helps to reduce noise and interference from other electrical systems. When using isolated ground receptacles, it is important to ensure that the isolated grounding conductor is connected directly to the clean ground bus bar. Another best practice is to use shielded cables for all data and communication connections in the server room. Shielded cables have a metallic shield that surrounds the conductors, providing protection from electromagnetic interference, or EMI. The shield should be properly grounded to the clean ground bus bar to ensure that it is effective. The use of surge protective devices, or SPDs, is also highly recommended in server rooms. SPD protects sensitive electronic equipment from voltage surges caused by lightning strikes, power grid fluctuations, and other sources. SPD should be installed at the service entrance and at the equipment level. The SPD should be properly grounded to the clean ground bus bar to ensure that they are effective. Regular inspection and testing of the grounding system is essential to ensure that it is functioning properly. Ground resistance testing should be performed periodically to verify that the grounding system has a low impedance path to ground. Visual inspections should be conducted to check for loose connections, corrosion, and other signs of damage. Any issues that are identified should be promptly addressed to maintain the integrity of the grounding system. The importance of proper grounding and bonding in server rooms cannot be overstated. A well-designed grounding system is essential for ensuring the safety of equipment and personnel, minimizing electrical noise, and preventing ground loops. By following the NEC guidelines and industry best practices, you can create a reliable and effective grounding system for your server room. Here are some additional considerations for grounding and bonding in server rooms. Firstly, consider the layout of the server room. The location of the clean ground bus bar should be carefully planned to minimize the length of grounding conductors. The bus bar should be located in a central location that is easily accessible. Secondly, consider the type of equipment that will be installed in the server room. Different types of equipment may have different grounding requirements. Consult the equipment manufacturer's documentation for specific grounding recommendations. Thirdly, consider the potential for future expansion. The grounding system should be designed to accommodate future growth and expansion. Ensure that there is sufficient capacity on the clean ground bus bar to accommodate additional equipment. Fourthly, consider the environmental conditions in the server room. Server rooms are often subject to high humidity and temperature fluctuations. These conditions can accelerate corrosion of electrical connections. Use corrosion-resistant connectors and materials to minimize the risk of corrosion. Fifthly, consider the use of a grounding electrode system that is specifically designed for sensitive electronic equipment. There are grounding electrode systems available that are designed to provide a very low impedance path to ground. These systems can be particularly beneficial in server rooms where electrical noise is a concern. Sixthly, document the grounding system thoroughly. Keep detailed records of the grounding system design, installation, and testing. This documentation will be helpful for troubleshooting and maintenance. Seventhly, train personnel on proper grounding and bonding practices. Ensure that all personnel who work in the server room are trained on the importance of proper grounding and bonding. This training should include information on the NEC guidelines and industry best practices. Eighthly, use a qualified electrical contractor to install and maintain the grounding system. A qualified electrical contractor will have the knowledge and experience to ensure that the grounding system is properly installed and maintained. Ninthly, regularly inspect and test the grounding system. The grounding system should be inspected and tested on a regular basis to ensure that it is functioning properly. Any issues that are identified should be promptly addressed. Tenthly, consider the use of a power quality monitor. A power quality monitor can be used to track voltage, current, and other electrical parameters. This information can be helpful for identifying and resolving power quality problems. By following these additional considerations, you can further enhance the reliability and effectiveness of the grounding system in your server room. Remember that proper grounding and bonding is essential for ensuring the safety of equipment and personnel, minimizing electrical noise and preventing ground loops. It is a critical component of a well-designed server room. And always remember to consult with a qualified electrical engineer or contractor to ensure that the grounding system meets all applicable codes and standards. This professional guidance can help you avoid costly mistakes and ensure the long-term reliability of your server room infrastructure. One should also consider the type of grounding electrode system used. While a typical driven ground rod is acceptable in many situations, alternative grounding electrodes may offer improved performance in certain soil conditions. These alternatives can include ground plates, ground grids, or concrete encased electrodes, often referred to as UFA grounds. The selection of the appropriate grounding electrode system should be based on a thorough assessment of the soil resistivity and the specific requirements of the server room equipment. Soil resistivity testing can be conducted to determine the resistance of the soil to the flow of electrical current. This information can be used to select the grounding electrode system that will provide the lowest possible ground resistance. Another important aspect of grounding and bonding is the proper selection and installation of connectors. Connectors used for grounding and bonding should be listed for the purpose and compatible with the materials being joined. For example, when connecting copper conductors to aluminum bus bars, it is important to use connectors that are specifically designed for this application to prevent galvanic corrosion. Galvanic corrosion can occur when dissimilar metals are in contact in the presence of an electrolyte such as moisture. The corrosion can weaken the connection and increase the resistance of the grounding path. Furthermore, the routing of grounding conductors is also critical. Grounding conductors should be run as directly as possible, avoiding sharp bends and kinks. Sharp bends and kinks can increase the impedance of the grounding path, reducing its effectiveness. Grounding conductors should also be protected from physical damage. This can be accomplished by running the conductors and conduit or by using other protective measures. In addition to the above, it's essential to understand the difference between grounding and bonding. Grounding refers to connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding refers to connecting metallic parts together to create an electrically conductive path. Both grounding and bonding are necessary for ensuring the safety and proper operation of electrical equipment. It is also important to consider the impact of electromagnetic fields, or EMF, on the performance of sensitive electronic equipment. EMF can be generated by various sources, such as power lines, transformers, and other electrical equipment. EMF can interfere with the operation of electronic equipment, causing data corruption, equipment malfunctions, and other problems. Grounding and bonding can help to reduce the impact of EMF by providing a low impedance path for the EMF to flow to ground. In addition to grounding and bonding, shielding can also be used to reduce the impact of EMF. Shielding involves enclosing sensitive electronic equipment in a metallic enclosure that is designed to block EMF. The metallic enclosure should be properly grounded to the clean ground bus bar to ensure that it is effective. When working on electrical systems, it is important to follow all applicable safety precautions. Always de-energize electrical circuits before working on them. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. Be aware of the potential hazards associated with working with electricity and take steps to minimize the risk of injury. Regular training on electrical safety is crucial for all personnel who work on electrical systems. This training should cover topics such as lockout/tagout procedures, arc flash safety, and the proper use of PPE. By following these safety precautions, you can help to prevent electrical accidents and injuries. Finally, remember that grounding and bonding is an ongoing process. The grounding system should be regularly inspected and maintained to ensure that it is functioning properly. Any issues that are identified should be promptly addressed. By taking a proactive approach to grounding and bonding, you can help to ensure the safety and reliability of your server room. So, to summarize, the installation of a clean ground bus bar, along with proper bonding of cable trays and racks, is not just a recommendation but a fundamental requirement for a safe and efficient server room. It's a multifaceted approach that involves understanding and adhering to the NEC guidelines, implementing industry best practices, and ensuring ongoing maintenance and monitoring. This comprehensive strategy will safeguard your equipment, protect personnel, and maintain the integrity of your data.